Okay, so before we begin, let's have an opening prayer. Let's bow our head and feel the presence of the Lord. Amen. So, good morning everyone. Okay. Miss Secretary, do we have any absentees today? Alright. Before we begin, I have here a short activity. So, in this activity, we have 4 table of values, which is divided into 2 sets. The table of values in color green and the table of values on color blue. So what you have to do is to observe these 2 sets of table of values. And after that, I will call someone to tell me what they have noticed between these 2 sets of table of values. Okay, for this one, I will give you 30 seconds to observe before I call someone. Okay, start. Alright, so anyone who wants to tell me what they have noticed between these 2 sets of table of values? Okay. Alright, so you're correct. So as you can notice in this sets of values, the first set of values in color green, or table of values in color green, when the value of x increases, the value of y also increases. While on the other set, when the value of x increases, the value of y decreases. And when the value of y increases, the value of x decreases. Okay, so this activity is connected with our topic for today. Anyone who have an idea what will be our topic for today? Okay, so no one. So our topic for today is direct variation. So our lesson's objectives: first, illustrate situations that involve direct variation. Second, translate into variation statement a relationship involving direct variation between 2 quantities given by a table of values, a mathematical equation, a graph, and vice versa. And the third one, solve problems involving direct and or direct variation. Okay? So, direct variation. There is a direct variation whenever a situation produces pairs of numbers in which their ratio is constant. This can be expressed into mathematical statement or equation as y is equal to kx, where k is equal to y over x is the constant of variation or constant of proportionality. This statement can be y varies directly as x, y directly proportional to x, and y is proportional to x. This statement means that for 2 quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. Okay? So, when the value of x increases, the value of y also increases. And when the value of x decreases, the value of y also decreases. So, according to this statement, this can be expressed into mathematical statement, or the direct variation can be expressed into mathematical statement or equation as y is equal to kx, where k is equal to y over x is the constant of variation. So we call k as the constant of variation or the constant of proportionality. And we can get the value for k using this formula. K is equal to y over x. Okay, so now let's have an example. The example number 1. Using his bicycle, Kyle travels a distance of 10 kilometers per hour on a steep road. Given the table of values, so when time r is equal to 1, the distance kilometer is equal to 10. When time r is equal to 2, the distance kilometer is equal to 20. When time is 3, the distance is 30, and so on and so forth. So we have here 4 tasks or questions. The first question is, show that distance d varies directly as time. So, to show that distance d varies directly as time, what we have to do is to get the ratio of distance and time. So, ratio is equal to d over t, or distance over time. So, for the first value, when distance kilometer is equal to 10, so our value for d is 10, and over the value for time, which is 1. So 10 over 1 is equal to 10. So for the second one, d is equal to 20 over t, which is 2. 20 over 2 is 10. 30 over 3 is 10. 40 over 4 is 10. 50 over 5 is 10. Okay, so as you can notice, d over t is equal to 10 is constant. So when we see constant, so it is not changing. So 10, so for the first value, we get the ratio 10. For the second 10, for the third 10, and for the fourth 10, and for the fifth, it also 10. Therefore, d varies directly as t. So don't forget that the value of our k, or the constant, is 10. So the second question, or the second task, draw the graph of d against t. So using a graph, we have to draw the graph for this table of values. So since the first value for time is 1, and when time is 1, our distance is 10. So 10 and 1, so this will be our point here. So for the second value, 2 and 20, so here is the point. So 3 and 30, 4 and 40, and 5 and 50. So as you can notice, the graph represents a straight line which is going upward, since the value for time and distance are increasing. They are both increasing. So when the time increase, the value for distance also increase. So the graph for this table represent a straight line going upwards. So direct variation can be expressed as into a graph which will form a straight line going upwards, but can also sometimes a straight line going downward when the value for an example is when the value of time decreases, so the distance will also decrease. So the graph for this table will be a straight line going downward. Okay, so is it clear? Okay, so let's move on to letter C. Write an equation showing the relationship between D and T. So, to write an equation showing the relationship between D and T, since we already get the answer for the constant of this table of values, or the ratio, which is equal to d over t, which is equal to 10, we can get the equation of variation for this table. The equation relating d and t is d is equal to 10t. So let's check if this is correct. So d is equal to 10t. So when the value of t or the time is equal to 1, multiply 10 times t or 1, 10 times 1, we'll get the distance 10, which is equal to 10. So when our value for t is 2, so 10 times 2, the value of our d is equal to 20. When t is equal to 3, 10 times 3 is equal to 30. So the distance is equal to 30. So okay, so that is correct. So letter D, how far Kyle traveled after 8 hours and 10 and 1/2 hours? So, since we already have the equation of variation from letter C, we just have to substitute the value of t to get the value of the d or the distance. So when our t is equal to 8, so d is equal to 10t, substitute the value for t. So 10 times 8 is 80. So, when Kyle traveled after 8 hours, he traveled 80 kilometers. But how about when Kyle traveled after 10 and 1/2 hours? So we will just have the same procedure. When t is equal to 10 1 and 1/2, d is equal to 10t, our equation of variation. Substitute the value of t, which is the given 10 and 1/2. So 10 times 10 and 1/2 is equal to 105. So Kyle traveled 105 kilometers after 10 and 1/2 hours. So do you understand? Alright, so let's move on to example number 2. Write an equation for the following statements. So we have to express these statements into an equation of variation. So a fare f of a passenger varies directly as the distance d of his destination. So for this one, for this statement, since always remember that the first variable before this statement that will determine this situation as an example of direct variation. So that statement is varies directly. So when you see it or when you notice this statement in a situation, you can already determine that this situation is an example of direct variation. So the first variable mentioned here is f. So f will be the variable on the left side. So f is equals to k. So as I mentioned earlier, k is the constant. So constant of variation or constant of proportionality times the destination. So since destination is mentioned after the statement varies directly. So f is equals to kd is the equation for this statement where k is equal to f over d. So to get the value for k, we have here k is equal to f over d. So k is our constant, remember. So another one, the weight W of an object is directly proportional to its mass m. So for this one, who wants to answer? Alright, so since W is the first mentioned before, the statement directly proportional, the variable W will be on the left side. So W is equal to K, our constant, times M, or the variable after this statement. So W is equal to Km as the equation for this statement, where K is equal to W over M. So we can get the constant for this statement by using this formula. K is equal to W over M. So letter C, the area A of a triangle is proportional to its height h. So okay, so for this one, A is the variable on the left one. So A is equal to KH or K times H, where K is equal to A over H. Okay. So, do you get it, class? Okay. So, let's move on to another example. Example number 3. If y varies directly as x and y is equal to 24 when x is equal to 6, find the variation constant and the equation of variation. So, variation constant is the k, and the equation of variation is, since y is the first mentioned here, so y is the variable on the left side, is equal to kx, or the constant of the variation, times x. So, to get the value of k, so we have to get the value of k first before we can get the equation of variation. So, since y is equals to 24, the value of y and x is given. For y is equals to 24 and for x is equal to 6. So, substitute the value of y, which is 24, and the value of x, which is 6. So, 24 over x, we can get the value of k, which is equal to 4. So, since we already get the value of constant of variation, we can substitute the k on this equation. So, we will have y is equal to 4x. So, this one is the equation of variation. And k is equal to 4 is the variation constant. Okay, so another one, example number 4. Find the constant of variation and equation of the variation in which y varies directly as x and y is equals to 51. And x is equals to 3. So, y is the first mentioned. Y is equal to kx. So, we have to get the value of k, or the constant first. So, k is equals to y over x. Y is the numerator since y is the one on the left side here. And x is the denominator. So, we have the value for y, which is 51. So, substitute the value for y, 51. And for value for x is equal to 3. So, 51 over 3 is equal to 17. So, we have the value for k, or the constant, which is 17. Now, we just have to substitute the value for k in this equation. So, we will have the equation of the variation, y is equal to 17x. Okay. So, another example. So, the table below shows the number of hours t traveled and the distance d traveled by a car. Find the constant of variation and the equation which describe the relation. So, given the table of values, we have the time r. When time r is 1, we have the distance kilometer, 40 kilometers. When 2, we have distance 80. When time is 3, we have the distance 120, and so on. So, to get the constant of the variation and the equation for this table, since we have distance is equal to, so kx, it should be kx. So this will be our equation, and this will be our formula for getting the constant of variation. So k is equal to d over t, since d is on the left side here of the equation. So k is equal to d over t. So we can choose any of this value for distance. So since 40 is the least number in this equation, in this table, we will get 40. So substitute the value of d to 40, and since this, when distance is 40, the time is 1, so substitute the t. with 1, so 40 over 1, we will get the value for k, which is equal to 40. Now that we have the value for k, we will just substitute the value of k on this equation. So we have this equal to 40t. So this is the equation of variation for this table. And this is the constant of variation for this table. We just have to substitute the k for the value of k here to get the equation of variation. So now let's move on to example 6. So if x varies directly as y and x is equal to 35, when y is equal to 7, what is the value of y when x is equal to 25? So first, let's have the equation here for x varies directly as y. So x is the first mentioned, x. So we can express this situation into a table of values. So the value missing here is the value of y when the value of x is 25. So from this statement, x varies directly as y, we can have the equation x is equal to ky. So the value of x is 35 and the value for y is 7. So we will have 35 is equal to k over 7. To get the value of k, we will divide both sides by 7. So we will cancel the 7 here. So 35 over 7, k is equal to 35 over 7, h is equal to k is equal to 5. So 35 over 7 is 5. Since we get the value for k, we will find the value of y when x is equal to 25. So we have here the value of k. So substitute the value of k in this equation. X is equal to 5y. So when x is equal to 25, what is the value for y? So substitute the value of x with 25 is equal to 5y. To eliminate the 5 here on this side, we have to divide both sides by 5. So y is equal to 25 over 5, which is equal to y is equal to 5. So the value of y when x is equal to 25 is 5. So another example. If y varies directly as x and y is equal to 24 when x is equal to 6, what is the value of y when x is equal to 15? So just like earlier, we can express this situation into a table of values. So y varies directly as x can be written in the equation y is equal to kx. So to get the value for k, we have to substitute for the value of y, which is 24, and the value for x, which is 6. To eliminate the 6 beside k, so we have to divide both sides by 6. So cancel the 6 here. So 24 over 6 or divided by 6 is 4. So we have the value for k, which is 4. Then since we have the value for k or the constant, we can substitute the value of k here to y is equal to 4x. So x is equal to 15 and y is equal to, so we have to find the value of y when x is equal to 15. So substitute the value for x from this equation. So y is equal to 4 times 15. So y is equal to 60. So when our x is equal to 15, our value for y is 60. So example number 8. A worker's paycheck P varies directly as the number of hours each work. For working for 20 hours, the payment is 1,000 pesos. Find the payment for 45 hours of work. So the first variable here is the paycheck or the variable P. So P, we have here the variable P on the left side. Varies directly. So this equation is an example of direct variation. As the number of RSA. So we have the second variation here on the right side. So P is equal to KH. KH is the equation for this statement. So for working for 20 hours, the payment is 1,000 pesos. So we have the value for the hours, which is 20 hours. And the value for the payment, which is 1,000 pesos. So substitute the P with 1,000 and substitute the H to 20. So we can get the value of K by eliminating the 20 here. So but to do that, we have to divide both sides by 20. So 20 over 20, cancel that. The K will remain. So from this side, 1,000 over 20 is 50. So we have the value for K or the constant, which is 50. Now that we have the value for K, let's substitute the value for K here in this equation. So we will have P is equal to 50H. Now we have to find the payment for 45 hours of work. So the given here is the value of H or the hours. So substitute the value of H here with 45. Okay, so 50 times 45 is equal to 2,250 pesos. So the payment for 45 hours of work is 2,250 pesos. Okay, so do you have any questions and clarifications about direct variation? So do you already understand how to get the value of K or the constant of variation from the given situation? Okay, so since you already know that and you can already get the equation, we will have an activity. So this activity consists of two items. So the first is find the constant of variation in which y is varies directly as x, and y is equal to 28 when x is equal to 2. The second one is find the equation of variation for item number 1. I'll give you 2 minutes for this one before we check. Okay, time's up. So let's check your answer. So for number 1, find the constant of variation in which y varies directly as x and y is equal to 28 when x is equal to 2. So since in number 1, we only have to get or define the constant of variation or the k. So first, we have to get the equation y varies directly as x. So y is equal to kx. So since the value for y and x are already given, we have to substitute the y with 28 and x with 2. So to get the value for k, we have to divide both sides by 2 to eliminate the 2 here. So 2 divided by 2, cancel that. So 28 divided by 2 is equal to 14. So we have the value for k or the constant of variation, which is 14. For number 2, find the equation of variation for item number 1. Since we already have the value for k, or the constant operation, we just have to substitute the value of k in these equations. We will have y is equal to 14x. So this will be our answer for number 2. Okay, so who got 2 points? Okay, so give yourself 10 claps. Okay, so who got 1 point? Okay, so give yourself 5 claps. Okay, so since most of you get 2 points, I assume that you understand my topic. So our topic for today. So for your assignment, we have here the weight of an object on the moon varies directly as its weight on Earth. An astronaut who weighs 80 kg on Earth weighs 12.8 on moon. How much would a 60 kg person weigh on the moon? Alright, so that's for today. Goodbye, class. Alright, so thank you.